Good day, viewers. Welcome to this class, and today we'll be looking at likely NEET Physics questions. So let's dive right into it. The first question here says, a light year is a unit of dash. Now, among the options here, we have time, mass, distance, and energy. Now, one of the units for measuring distance is called light year, and the unit for measuring distance in space. So the correct answer is option C, which is distance. That takes us to the next question, which is, the magnitude of any physical quantity dash. The magnitude of any physical quantity dash. Option A says it depends on method. Option B says it is independent of method. Option C says it is greater in SI than CGS. Option D says it is proportional to mass, length, and time. Now, the magnitude of any physical quantity is independent of method. It does not depend on the method. So, irrespective of the method, the magnitude of a physical quantity will remain the same, irrespective of method. So, the correct answer here is option B. So, that takes us to the next question, which says, which of the following is not equal to what? Which of the following is not equal to what? So, option A, we have joules seconds. Now, your joules seconds is the same thing as saying that I have work done. Okay, joules per second. That's what I have there. So this is work done over time. And we know that work done over time is power, which is the same thing as what? Watt. So watt is the unit for measuring power. So option A is a unit of is equal to watt. Option B says I have ampere volt. Ampere volt. An ampere volt is the same as saying I have current times voltage. And my current times voltage is the same as what? Power, because power is equal to what? IV. So it means therefore that this is also equal to watt. Option C says I have ampere square ohms. So ampere square ohms. So I have ampere square ohms. This is the same as saying I have I square R. So ampere square is current square times resistance, and I square R. Since we know that P is equal to IV, and we know that V is equal to IR. Anyway, I see V, if I change it to IR, it means that my power is equal to I square R. So this is also equal to watt. Then I have ampere per volt. So ampere per volt here is simply saying current over voltage. Current over voltage. And we know that V is equal to IR. This is the same thing as saying that if I'm saying I have current over voltage, here is like saying the reciprocal of resistance, because no matter resistance will give me voltage over current. So the reciprocal of resistance here therefore will give me current over voltage as what? The reciprocal of resistance. And we know that the reciprocal of resistance is what? The capacitance. So therefore it means that this one here is not equal to the unit of power, which is what? Watt. So the correct answer to this question is option D. So that takes us to the next question, which says Newton second is the unit of dash. Newton second is the unit of dash. Now when we talk about Newton seconds, what we're simply saying there is force times time. So Newton seconds is the same as in I have what? Force times time. And force times time can also mean that I have what? Impulse. Because impulse is simply the force times the time. But there, looking at our option, we do not have what? Impulse. So looking at this, if we simplify this, this is the same as saying I have mg times t, which will also mean that I have kilogram meter per second square. So I have meter per second square times seconds. So this will give me kilogram meter per seconds. So looking at this, kilogram meter per seconds. So if we look at each one of these, velocity there is measured in meter per seconds. There's no kilogram. Angular momentum here angular momentum. Then we have energy. Energy is also not this. So looking at this, we know also that momentum is mass times velocity, which is same as in kilogram meter per second. So the correct answer to this question is linear momentum, not angular momentum. Option C, which is what? Linear momentum. So that takes us to the next question. We said 1 second equals dash. Please note that 1 second is equal to 9,192,631,770 period of the CS atom clock. So the CS atom clock is the standard of measurement for measuring seconds, and that is where what our time or unit of time was derived from. So the correct answer to this question is option C, which says what? That 1 second is equal to 9,192,631,770 period of the CS atom clock. So that takes us to the next question, which says 1 nanometer is equal to. So when we say nanometer, what we simply mean here is the submultiple nano as it is used. So when we say nano, nanometer as in this case is equal to 1 times 10 raised to power minus 9 meters. So 1 nanometer is 1 times 10 raised to power minus 9 meters. So let's look at our options here. So all our options, we have millimeters and centimeters. So we have to convert this to be in millimeters and to be in centimeters and find out what the answer will be. So in order for us to convert this to be in millimeters, in centimeters to start with, this is the same thing I have. I'll have to divide this by centi. So that will give me that I have 1 times 10 raised to power minus 2, because centi is times 10 raised to power minus 2 as well. So this will give me what? Minus 7. So this will give me centimeters. So 1 times 10 raised to power minus 7 will be what? 1 nanometer in centimeters. So if I want to convert it to be in millimeters, that will give me 1 times 10 raised to power minus 6 millimeters. So what I've simply done here is to ensure that each one of these, so if you spread this out, this is the same as in I have 1 times 10 raised to power minus 7 times 10 raised to power minus 2, because centi here means times 10 raised to power minus 2. So this one is the same as in I have 1 times 10 raised to power minus 6 times 10 raised to power minus 3, because milli here means times 10 raised to power minus 3. So at the end of the day, I'm going to have what? This added to this, you have what? Minus 9. This added to this, you have what? Minus 9. So we either have it in this format or we have it in this format. So we are looking for either 1 times 10 raised to power minus 6, or we are looking for 1 times 10 raised to power minus 7. So looking at our options, we see that we have what? Option A says we have 10 raised to power 9 millimeters. That is incorrect. We have 10 raised to power minus 6 centimeters. That is incorrect. We have 10 raised to power minus 7 centimeters. That is correct. It means that the correct answer to this question is option C. So that takes us to the next question, which is a stone is dropped from a tower of height 180 meters. So we have the height of the tower to be 180 meters. The time to reach the ground is dash. So we are looking for the time. We do not know. Now, because it was dropped from a height, it means that the initial velocity is 0 meter per second. And because it was dropped on the earth surface, it means that my acceleration due to gravity is 10 meter per second squared. So with this, all I have to do here is what? Calculate with this. And we know that H is equals to UT plus half GT squared. So this is the same thing as saying that I have. This will give me 180 is equals to 0 times T plus 1 over 2 times 10 times T squared. So this will give me 180 is equals to 5T squared. So I have 180 divided by 5. That will give me 36 is equals to T squared. It means that my T is equals to 6 seconds. So it means that it will take 6 seconds for this stone to get to the ground, which is what option B. So that takes us to the next question, which says a ball is thrown downward at 10 meters per second from 100 meters. Time to reach the ground is that. Now this question is quite different from the one we just solved, because in the previous one we solved, it was dropped from rest. So because it was dropped from rest, the initial velocity there was 0. But in this question, we're given the velocity with which it was dropped. Here we have a stone is thrown downward. So our initial velocity was given as 10 meters per second. And then it said the total height it covers is 100 meters. And we're asked to find the time. So since we have all of these parameters, all we have to do is use the same formula, since we know that our G will also be 10 meters per second squared. So we know that my H is equals to UT plus RGT squared. So this is the same thing as saying I have 100 is equal to 10T plus 1 over 2 times 10 times T squared. So this will give me 100 is equal to 10T plus 5T squared. So if I rewrite this is the same thing as saying I have 5T squared plus 10T minus 100 is equal to 0. So this is a quadratic equation. So since this is a quadratic equation, it means that if we compare the quadratic equation that says ax squared plus bx plus c to be equal to 0, it means that my a here is 5. It means that my b is 10 and my c is minus 100. So with this, we know that our formula simply says that my t in this case will be equals to minus b plus or minus square root of b squared minus 4ac all over 2a as the quadratic equation formula. So with this, we know that my t therefore will be equals to minus 10 plus or minus square root of 10 squared minus 4 times a there is 5 times minus 100 divided by 2 times 5. So this will give me minus 10 plus or minus square root of 100 plus. So if I multiply this times 100 here, so this will become plus, minus times minus will make it plus. 20 times 100 here will give me 2000. So divided by 10. So this will give me minus 10 plus or minus square root of 2100 over 10. So I have, this will give me minus 10 plus or minus 45.8 over 10, which is the same as saying that I have minus 10 minus 45.8 over 10, or minus 10 plus 45.8 over 10. So this will give me 35.8. So that will give me 3.58 seconds, which is approximately 3.6 seconds. So looking at our options, we have 3.6 seconds here, and our options here, we have 3.2 seconds, we have 4 seconds, we have 2.5 seconds, and we have 5.3 seconds. So if you approximate this is the equivalent to saying I have 4 seconds. So the correct answer to this question is 4 seconds. Now, if you look here, we have what? Negative also. We did not bother solving the negative because you cannot have what? Negative time. So the time taken for it to reach the ground is 4 seconds, which is what? Option B. So that is the next question, which says a body takes 0.5 seconds to travel last 19.6 meters freely, falling from what height did it fall? So we're given that we have what? The time. as 0.5 seconds, and we're given the distance it traveled in the last 19.6 meters. So let's say let the total time be capital letter T. So that would mean that, let's say this is change in my small letter t, and this is change in the distance. So let's use change to differentiate this time from my total time as well as the total distance. So with this, we know that the distance covered in this 19.6 meters would be equal to 1 over 2 g open bracket t squared minus, so I have t minus change in t squared. So if I simplify this, this is the same thing as saying I have my change in this distance to be equal to 1 over 2 in bracket g. So this will give me t minus change in t in bracket t plus, because this is difference of 2 squared, t minus change in t. So if we simplify further, this will give me 1 over 2 g open bracket t minus t plus change in t in bracket t plus t minus change in t. So this will give me 1 over 2 g in bracket change in t, then I have 2t minus change in t. So if I simplify further, I'll have 1 over 2 g in bracket 2t change in t minus change in t squared. So with this, if I impute my values, this is the same thing as saying that I have, since my change in s, so this is change in s, change in s, change in s. Since my change in s is 19.6, so I have 19.6 is equal to 1 over 2 times my g is 10 meter per second squared. So this will give me times 10 in brackets 2t times my change in t was 0.5. This is minus 0.5 squared. So this will give me 19.6 is equal to 5 in brackets 2t times 0.5 here will give me t minus 0.5 squared will give me 0.25. So if I simplify further, I'll have 19.6 is equal to 5t minus 1.25. So if I collect like terms, this means that I have 5t to be equal to 19.6 plus 1.25. So it means that my 5t will be equals to 20.85. So if I divide both sides by 5 divided by 5, it means that my t will be equal to 4.17 seconds. So this capital letter T, sorry. Now in the question, we are now asked to find the what time. Instead, we are asked to find the height. So we know that the height is supposed to give me half g t squared. So this will give me that the height is equal to 1 over 2 times 10 times 4.17 squared. So I have 10 times 4.17 squared. So I have 173.889 divided by 2. So that will give me 86.94, which is approximately 86.9 meters. So it means that the height from which this body has been falling is 86.9 meters. So that takes us to the next question. If F is equal to mv squared over r, dimensional formula will be, so if my F is equals to mv squared over r, we are asked to find the what dimensional formula. So we know therefore that this is the same as say that my F is equals to, my M here is talking about mass, so that is kilogram here. So I have, let me simplify it. So this is mass times, so this is velocity squared over your radius. So this can be simplified further to mean that I have mass times velocity here is displacement over time. So I have displacement over time divided by radius. So this will mean that I have mass here is still mass times displacement is measured in meters, so it's a function of length over time divided by radius here is also a function of length. So it is still length. So this will give me, so this is squared. So I have mass times length squared over length times time squared. So the square here will cancel out this length. So I'll have mass times length over time squared, which is the same as saying I have ml t raised to the power minus 2. So the dimension is ml t raised to the power minus 2. Looking at our options here, ml t raised to the power minus 2 is option A. So the correct answer here is option A. So that takes us to the next question, which is, if radius of a sphere has 2% error, error in volume is dash. So if the radius of a sphere has 2% error, so we know that the volume of a sphere is 4 over 3 pi r cubed. So it means that since I have 2% error in the volume, this is the same thing as saying that I have my change in volume over volume, therefore will be equal to, because of this raised to power 3 here, this will give me 3% of my change in radius over the radius. So this is the same thing as saying, so we know that my change in radius over the radius here is the same as the percentage I was given, which is what? 2%. It means that my percentage change in volume therefore will be equals to 3 times 2%, which will give me 6%. So it means that the correct answer to this question is option C, which is what? 6%. So that takes us to the next question, which is a body projected vertically upward, which remains constant. So now when a body is projected vertically upward, they're asking which of these quantities will remain constant, which will not change. Will the velocity not change? Will the acceleration not change? Will the kinetic energy not change? Or will the momentum not change? Now when the body is projected vertically upward, the velocity constantly changes. The momentum also changes, as well as the kinetic energy of the body also changes. The only thing that does not change is the acceleration. Because the body is projected on the Earth's surface, the only acceleration acting on it is acceleration due to gravity. So, and that does not change. It will remain as 9.8 meter per second square, or approximately 10 meter per second square. So the only thing that is not changing there is acceleration, which is what? Option B. That is the next question, which is, if A is equal to 3I plus 4J, angle with x-axis is dash. So this is vector, and this is what we call unit vector. So I have this. So in order for me to find the angle, I know that my angle is always tan theta is equal to opposite over adjacent. And in this case, anytime you have something like this is the same as saying I have tan theta is equal to coefficient of j over coefficient of I. So this is the same thing as saying I have my tan theta to be equals to 4 over 3. And that will give me that theta is equals to tan inverse of 4 over 3. That will give me 53.1 degrees. So looking at our option, there's no decimal point. It means it's approximately 53 degrees. So the correct answer to this question is option D, which is 53 degrees. So that takes us to the next question, which is scalar product of two vectors is maximum when the angle is dashed. So when you have the scalar product of two vectors, it means the product here of two vectors is supposed to be in the format of AB cos theta. So AB are fixed, but my cos theta will be maximum only when my cos has the highest value, and the highest value of cos is 1. So if my cos is to have a highest value of 1, the only time you can have cos 1 is when the angle given is 0. So my product of two vectors will have the maximum value if cos theta is equals to cos 0, and that is when it is equal to 1. So the correct answer is when the angle between them is 0 degrees, which is option A. So that is also the next question, which is escape velocity on Earth is about dash. So for us to find the escape velocity on Earth, we need the constant of Earth. Since we know that escape velocity is supposed to give me square root of 2gm over r. So I know that my g, gravitational constant, is 6.67 times 10 raised to the power minus 11 Newton meter square per kilogram square. The mass of the Earth is 6 times 10 raised to the power 24 kilograms. Then we have the radius of the Earth to be 6,400 kilometers, which is equivalent to saying I have 6.4 times 10 raised to the power 6 meters. So if I impute my values, it means that my V is equals to square root of 2 times 6.67 times 10 raised to the power minus 11 times 6 times 10 raised to the power 24 over 6.4 times 10 raised to the power 6. So this means that my V is equals to square root of, if I multiply all of these, I'll get, so I have 6.67 times 2 times 6. That will give me 8 times 10 raised to the power 14 over 6.4 times 10 raised to the power 6. So I have so this will give me that my V is equals to square root of 125,000,000,000,000 000. So square root of this will give me 11180.3, which is the same as saying that I have 11.18 kilometers. So looking at this, if you approximate this, that will give me the same thing as what I have there, as 11.2 kilometers per second. So the correct answer to this question is option C. That is also the next question, which says the work done in stretching a spring of constant K by X is dash. Now the work done on the spring is given as W is equals to 1 over 2 Fx. And we know that my F is equals to Kx from Hooke's law of elasticity. So with this, we know that my work done is equals to 1 over 2 Kx squared. So the formula for calculating the work done on an elastic material such as a spring is 1 over 2 kx squared, and none of the option here is correct. Moving on to the next question. It says two resistors R1 and R2 in series have equivalent. So when resistors are connected in series, you calculate them thus such that your R total is equal to R1 plus R2. So long as they are connected in series, you simply what? Add the resistors together, which means that what? The correct answer here is option A. So we've come to the end of today's class. I believe you had a wonderful time. Don't forget to go to the channel for more videos just like this.
Hi, I'm sure you enjoyed the content you just watched. To see more episodes as that, preparing you for your oncoming exams, smash the subscribe button on this channel right now and visit the playlist that we've made for you, covering over 50 type of different exams, including JAMB, WAEC, Kakao,